Hello viewers, robotic team members, or anyone else just interested in computer-aided design for FRC. Welcome to Herndon Robotics' first FRC for CAD, or CAD for FRC, sorry, tutorial. In this one, we're just going to create a simple frame and talk about variables and such like that. I do recommend looking at our organization structure so you know what I'm showing you here. But yes, I'm going to try and speedrun this because I've already done this a couple times. As you can see here, we have different folders: quick sketches, prototype, final. As I go to BAMF, you've seen I've done a frame a couple times, welding, teaching some people, Catherine. Come back to final design. I will be doing this in here, but we can go to BAMF, and you see another frame. Anyways, we're just going to go right into this. This BAMF will be for welded frames. If you are not using welded frame, I don't know what to tell you. Like, we're using custom frames. It doesn't necessarily need to be welded, but I was told for the frame you should have it welded. But more importantly, this is for those who are doing custom frames, not pre-made frames. Gearboxes and stuff are fine, but if you're doing like pre-made things, there's already normally files, which take up a lot of less time. Anyways, we're going to go on and save, and as you can see, this will be used as our FRC CAD. My apologies for my loud keyboard. I'm just going to name this tutorial, BAMF, and save. So, lucky me is I remember all the dimensions quite well. So, before we do anything, I'm going to pull up a quick Microsoft Paint sketch to show you what you might get from your BAMF members. I don't even remember what BAMF is for, but it's basically the frame, the wheels, basically the base of the robot. And I'm going to go pull up that. So I have just quickly made a little mock-up, and I will explain what all these are. So let's look at this area first really quickly. As you can see here, our frames that we custom weld are made up of aluminum tubing. It's a square on the inside, and there are a couple things that you need to know about it. So we use typically 1 inch by 1 inch aluminum tubing, and then from there we use 1/8 inch thickness, I believe. And by thickness, I mean right here, this distance right here. Let me get a brush. This distance right here is 1/8 of an inch. This one is 1/8 of an inch, so it's 2/8 of an inch, or 1/4. So this is 3/4 because this is 1/8 and 1/8. So together it's 2/8 of aluminum on both sides, and then we have 2/8. That's 1/4, and then the rest of the 1 inch taken up is 3/4. I'm hoping you're following the basic math I'm trying to explain. So this is 6/8 right here. So zooming out, we have our aluminum square tubing. And because we're dealing with tubing, you need to remember a couple things. One, tubing, because you're cutting all the pieces and then connecting them, making them go together, this is going to be something like this. So if I draw this at an up angle, or from a top-down view instead of a side view, if you want one piece to be 7 inches and another piece to be 8 inches, or you want the length to be 8 inches and let's say the height in this case to be 7 inches, this piece here can be, let me change my color. This piece here can be 7 inches, but if you want this piece to be 8 inches, or if you want this distance from here to here to be 8 inches, you won't want to cut a piece that's 8 inches, because if this is 8 inches, you still have to add the 1 inch from here, if that makes sense. So you have your 1 inch, because we said it's 1 inch wide for the tubing, and then your 8 inch here. We know that, well, 1 plus 8 is 9, so technically this is your length of 9 inches. So that's why you have to discuss things with BAMF, because sometimes it's overlooked. I know I have to sometimes give a general nudge and just say, hey, don't forget you have to deal with this. And like, oh yeah, it's just something they oversight because the BAMF is normally a group that is stressed really quickly to get done, is the frame and base of the robot, because everything else gets built around that. So with that in mind, we went with a square frame this year, so we'll be using 29 by 29, and I'm going to refer to these as length and width. And when I say length and width, I normally think of a rectangle that has a length, or a width, that is bigger than the length. So width is greater than length. And in my designs, I will also make the tubing for the width side like this, and the length like this. So if you look back to here, let's say the width was 20 and the length was 10, the length would actually only be 8, because in order to get from here to here, you would need 1 inch here and here to get 10. So that's just your basic length, width, and everything else. So now we're going to go and actually model it. So you can just have these set as values, but we're going to use variables instead. And if you take an algebra, you know what variables are. You take programming of any kind, you should know what a variable is. And for those who don't know what a variable is, I actually don't know the best way to explain it, to be honest. You can think of it as just a value. So I guess it's got a really random text. You can think of it as a value. Sorry, I got a really random text. You can think of it just like a value you can set and change. So in order to access our variables in Fusion 360, I don't know what you're using. If you're using Onshape or anything else, you're out of luck. Maybe I'll make an Onshape tutorial, but we personally use Fusion 360. We're going to hit Modify, Change Parameters. And I'm going to make this very basic, so everyone who sees this can follow along very easily. No matter what skill level you are with Fusion or any CAD software. I will not be doing basic move. You can go to our other tutorials for basic moving, but yeah. And you'll notice I saved this file as tutorial BAMF by just hitting the save, because if you save an untitled thing, it'll prompt you to save it. So there's that aspect. Anyways, modify, change parameters. So change parameters, parameters basically means variable. So we can have a user variable. We're going to name it width, and we're going to set to our width, in this case 29 inches. We can add a comment. Hi, hello world. There's like your programming reference. So then we have our width, and our length is the same. So name the thing for the length, 29 inches, and there we go. And just to get us started, I'm going to, I've already been recording for 8 minutes, going to set a variable for thickness. And we're going to, you can't actually do 1 divided by 8, but you can. Okay, that didn't happen before. Alright, so we have 1/8 inch value. So you can see you have an expression here for math, and then your value is different. Because let's say you take your, I'll delete this in a second. If you take length, which you can pull up a variable you have by just starting to type it and then hitting enter, times width, plus 1. Is length, is that not how you do times? You do length plus width, why not width times width? I don't even know why that's a thing. Anyways, so if you add them together, you get 58. So your expression is basically your equation, and your value is what you get when you plug in the current numbers in the variable. And we can delete a variable by coming here and just hitting, hovering over it and hitting the X. So we have our length, our width, and our thickness. So now we're going to hit OK, and we're going to start creating a sketch. So we're going to create a sketch. I will not create on the top plane, because when you create something on the top plane, you would have to then rotate it, and the way we're going to basically extrude it is, it's just not in our favor. I'll show you in a second. So we're going to create a plane on the front or the right. this is the front or the right doesn't matter. As you can see on the cube, they're all like, you can just rotate it this way. You don't rotate it vertically, you just rotate it horizontally. So now we're going to create a rectangle by just clubbing up here and clicking 2-point rectangle. And then you can see we're moving it around. Now, I know all my tubing is going to be 1 inch. I'm 99.999% sure it's not going to change. So I'm just going to set it to 1 inch, no variable needed, hit enter. So we have a 1 inch by 1 inch square. Then we're going to create another square, make it any size we want, doesn't matter, as long as it fits within here. Then in the top, we're going to go to sketch dimension. And if you never see any of the things that I'm talking about, it's most likely because your formatting for your GUI is just different. So we're going to go to create sketch dimension. So if you click on this menu, same thing here. If parameters was actually up here, you'd see it. So sketch dimension's up here, or you can go in the menu. So then we're going to make a sketch dimension. We're going to select this line, hit OK, and then we're going to set this to our thickness. Hit enter. So you see how this actually shows f of x instead of 1 inch, it shows f of x. Set this to thickness. Set this by selecting these two again, thickness, select this to thickness. Now we have an outline of our aluminum extrusion. Great. Now we need to go ahead and do the rest of it. So as you can see here, I normally make my width the longer one and the length the shorter one. So you see, I set my width and length to 29 by 29, even though I know the length needs to be made shorter. This is because it's just easier for them if BAMF changes the perimeter and they just say this is 35, this is 35, so that'd be 70 minus 120, so this would be 25 and this would be 25, in order to stay within the 120 inch limit. It's just easier to change it that way. So now we're just going to come here. We're going to extrude it by hitting E, and you'll get an operation for new body. We're just going to leave it with that. We're just going to extrude it, and like I said, you could do the value manually, but I don't like doing that for this case because we want a variable. Because let's say they're constantly changing it in design and prototyping. This is more final. I know my final one, but I just want it to be a variable just so, one, I get the practice dealing with variables, and two, it's more, I think in my opinion, professional in case if they really need changes, you can get changes done. So we're going to set this to the width and hit enter, and then hit enter again. So now we have one thing, the width, which is 29 inches, as you can see here. I got the measure tool by hitting measure. And then I'm going to bring up the browser. I'm just going to hide that. So I brought up the browser, and we're going to go to bodies, and body 1, and I'm going to rename this width. So then from here, I'm going to hide width, and I'm actually going to go to sketches and unhide this sketch and extrude something that is our length. And now we have a width and a length. Rename this to length. However, there's an issue with length. And the issue with length is it's the same as our width, and like we said, we don't want that. So we're going to edit this feature, and we're going to make a length, and I'm just going to pull up the drawing again. As you can see here, if we create, I just do this as the typical drawing. As you can see, the two length sides are shorter. This is because you need the room for the pipe here, and room for the pipe here, tubing, piping, whatever. So you can just draw it in, but I just like doing it like this. It's easier and faster. As you can see, if you wanted something 29 inches, this would need to be 27 inches, because 1 inch here, 1 inch here. So I just take my length, and I subtract 2, and then I hit enter. So now we have a width and a length that is proper sizing. And how I edited my extrusion is I just went to the extrusion, and I hit right clicked on it in the timeline, which is at the bottom here, and I hit edit feature. And I was able to change it. Now I'm going to move these out of the way. So I'm going to just select both of them by holding shift or control and selecting them in the top bar, moving them over to the right. And I'm going to move one of them again just so we don't have to see them. So now what I'm going to do is we're going to start making the frame. I'm just going to hit A for appearance. You don't have to do this. I just like it because it's more visually appealing. I'm going to, this will pull up appearances, applies to the bodies and components. We're going to go to metal, aluminum, aluminum polished. And polished basically just means if you render it, it'll be more polished, which I like. At least that's how I think it would be based on its description. There's plenty of other options. You get, I can't even begin to pronounce some of these. You can make a brass robot if you want to be funny, but nickel, platinum. I haven't actually tried mirror. You'll find plastic and paint is very useful for just matte colors, like a red matte. Anyways, I'm off topic. Here is our 2 bars. So we're going to take our length, and I'm going to just click on it in this menu here, hit M to move it, and then we're going to rotate it this way to get 90 degrees. And then we're going to go point to point move, and I'm just going to select this point and this point. So what I did was I free moved it 90 degrees, and then by moving it point to point, I basically say this point and this point should touch, and this point was here, this point was here, this point was here, and then I was like, make them touch, so it made them touch perfectly. And we have our frame kind of built. Next thing we're going to do is we are going to, actually don't need any of these. No, wait, do I actually need them? I may need them. I don't know. I like to keep a clean timeline personally, but I know it's kind of difficult to do that. So I guess I'll live with these moves. It's whatever. So now we're going to go to length and width, and I'm actually going to select both of these. Hit Control C again. Or I'm going to hit Control C, Control V while they're selected, and it would let me copy paste them. If not, you can just extrude them again, but I'm lazy. And then I'm going to rotate this 180 degrees because it should automatically bring up the move option. And then you can just drag this ball to get it closer because we're going to move point to point. It's just the rotation that matters. So as you can see, we have our 2 pieces of the frame. This ball's very challenging in 3D space, as you can see, because here it looks like almost perfect, but yes, anyways. So then from here, we're going to go point to point. We're going to select this point and this point. And now we will have our frame. As you can see, it matches exactly what we were talking about earlier. If I go to the MS Paint drawing, the width and width are longer. And if I come here, the width is 29 inches. This is 27 inches. But if I measure here to here, that's 29 inches. In fact, it's the whole thing into the equation. Great. Now we need the height. So we're going to go and make a new variable. And change parameters. We're going to get a height. Because I'm just going to put on the site height, 5 inches. Okay. I don't even know if I'm doing height right. On our team, you need some thickness. This is not enough to like mount securely the frame to, at least in my opinion. We're gonna come here, we're gonna extrude by height, but we're gonna have the same thing with the length, where if we create a robot like this is our frame, and we have a height here, you need to account for the 1 inch of aluminum on the top and the bottom, here and here, because we have that here. So if the whole thing is 5, you're going to subtract 2 from it. So it's going to be height minus 2. Hit A for appearance. Aluminum polished. Then I'm going to name this height. Hope I spelled that right. I'm going to select it. I'm going to move it. Move it this way. Rotate it 90 degrees. Point to point. Here to here. Going to just, did I not save? I named it height. Move it over here, here to here. Do the same thing again. I'm not selecting the old one because it would definitely be twice as fast, but I want to try and make this look neat. It doesn't matter. Okay. I was trying to get it to do a nice order of 1, 2, 3, 4, but Fusion likes to be Fusion, and it will do whatever it wants sometimes. See, now this says height 2, but I want it to be 1, 2, 3, 4, whatever. So this will be, or 1 technically, it's just height, and then it does 1, 2, 3. So now we have 1, 2, 3, and then 0 technically, but it's just height, and it's out of order. Next, all we're going to do is we're going to copy the length and width, Control C, Control V. We're going to move this up a decent amount, and you could just move this up 4 inches, but the issue is if we change the height, it won't work. So then I'm going to do point to point, here to here, and now we have a decentish frame of our robot. Now what we need to do is we need to, I'm going to show off that our parameters work. So if I come here to change parameters, first I'll show you the most important one. I just think it's thickness. So if we change our thickness to 1/4 of an inch, it gets thicker. 1/3 of an inch, even thicker. I do 1/10 of an inch, very not thick. 1/120th of an inch, even less thick. Oh, well, I'm gonna do, okay, 1/8 of an inch. If I change the height to, let's say, 7 inches, the whole thing goes up. If I change it to 13, the whole thing goes up. Set it back to 5. 29. I could technically make it so this is really just 1/4 of that, but that'd be kind of a pain, to be honest. So yeah, I'm actually gonna favorite these because this would be really nice to pull out again and again. I'm gonna unfavorite them though. Anyways, because I've already done this, I don't think I'm gonna be doing it again. We now have our frame. If you can see, if I make this 40, if I make our width 40, the whole thing extends. If I make this 30, the whole thing extends. Bada bing, bada boom. 29, 29. We have our frame. There's nothing hidden over here. I just wanted you guys to see it update in real time. Now we're going to create the length, and the way I've been doing it is I was told just to make it parallel to this. We've been recording for 22 minutes. Hope this is not too boring. We have our length, Control C, Control V. We're going to move it, and to be honest, we don't move it by any specific parameter, which I guess I probably should do now. We're going to create a new parameter, and we're going to make it called wheel spacing, because why not? No, so that's because in these little channels that we're creating, it's where the wheel will go. So I'm going to move the length over, Control C, Control V. I'm going to put it right point, move this over here. So point to point, move this amount by wheel spacing, because in this little trench is where the wheel will sit. Then we're going to create another one on, it can be the same side, whatever. Here, here, and you get negative wheel spacing. And yours may be positive, negative, whatever, doesn't matter, as long as it all makes sense. Now if I come here, change parameters, wheel spacing, if I set this to 6 inches, it should increase. If I set this to 8 inches, it's not increasing. This is sad. I don't know why it did not increase. That's a good question. I really want that to be dynamic. So let's try this again. This is live testing. You get a live feedback, Control C, Control V. If I do this in one move, point to point move by wheel spacing. And if I modify the variable for wheel spacing, say this is 5, then will it work? No, it won't work. Ah, that's annoying. What if I align? What does this do? No. I'm trying to really think of a way. I don't know why it won't let me. Assemble? Maybe. Maybe assemble would be it. We'll need to make these components to make it a rigid group. Anyways, that's a little annoying. We can't just update that, but whatever. We'll go to this length. At least we have an initial variable to set it off from. Plus, we'll be using it again in the future. Point to point, free move, 3 inches. You can see it here or here. Boom, we now have our wheel. Next, we need to create a little bit more support in the back. I was told they want this is at least what I was told. They may change on this. Make this a bit bigger. Zoom it over here. So in the back half of the robot, we have. I'm just gonna do this. It's easier. Boom, 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 boom. In the back half of the robot. So we're going to be doing it this way because this is actually the length. We're doing it along the length or perpendicular to the length. So take this, zoom in. Okay, so the way this works is, at least the way they're developing it, is this right here, this gap. From here to here is 1/3 of the entire length. So that's 1/3 of the entire length. So I'm going to extrude this by that wheel spacing, because we're going to need something for wheel spacing, -2. Actually, what if I don't want it to be that. Let's make this, because the wheel spacing was 5 because I set it to 5 because we were testing it. We want wheel spacing to be 3. That's how much room we want for the wheels. So we're going to extrude this by 3. Not 3, by wheel spacing. Which won't move this, but it's not the end of the world. Actually, wait, we could do something maybe. We'll check that out in a second. So I'll name this crossbar. And then I'm going to take crossbar. I'm going to move it point to point here to here. And then we're going to move it to the right. So this point is 1/3 of the entire length. Because this is length, yes, you can tell because the width would be showing the whole, or would not be showing the whole like this. If we look on the length side, it will be showing the whole. Great. So we're going to make this 1/3 of length. Okay, 1/3. No, this way. Wait. 0. 0. 1/3. Hold up. Take crossbar. We're going to move it back, or z distance in the positive direction, by 1/3 of the length. 1/3 of length 1/3 times length. But length is 29. And the thing is, that's not 1/3 of the whole thing. They want 1/3 of this length. And this length is length minus 2. Because remember, this whole thing is length minus 2. So 1/3 of length minus 2 gets us 9. Because, if we'll paint, if we said our length was 27, and we split this into thirds, this would be 9, 9, 9, 9, 18, 27. And then this would be the crossbar going right here, because it's this edge to this edge is 9 inches. At least what they told me when I was asking the damn captain. Now all I'm going to do is from the crossbar, I can extrude. Again, I can literally just copy the crossbar. I can copy it and just move it 24 inches. It's fine. Really wish there's a more precise way to do this, but apparently the move tool doesn't like to work with me. So we have 27. I'm going to set this to aluminum. Tip, anything you use in a model will show up again right here. So I can just go ahead and drag and drop it instead of having to scroll set to metal all over again. The last thing we're going to do is add this crossbar and create a rigid joint. So we're going to create another crossbar, and we're going to use a lot of math for this one. So we're going to extrude this by, we want this interior minus these two, minus these two. So we want the length. So we need the length again, length or width. Let's say width. Width would have been better. Yeah, width, we should have really used the width for this. Actually, no. For the displacement, we should have used the length. For this, we should have used width. Whatever. So we're going to take our width and subtract 2. Width minus 2. And then we need to subtract another 2 here for these 2 bars. So plus a negative 2, just to keep formatting. And then we're going to also add another, we're going to add a negative 2 times wheel spacing. No. Wheel spacing. And this should now work. And basically how we got this equation was crossbar 3. I'm actually going to make this crossbar 2. And make this crossbar 1 because I want them to be technically in order. Whatever. So I'm going to move this here, point to point, point to point. Move this 1 inch over, and it's perfect. Okay. And now we have our BAM frame for this year, at least. And the moving of these, like I said, it's kind of annoying, so it probably won't work. But that's a minor fix, and this other things should technically work. I'm really annoyed. I'm gonna see if there's a way I can fix that. Either way, the way we did this math for crossbar 1 is we did, like we originally said, move over here. We did width minus 2 to count for the 2 bars here and here, because we're only doing it from here to here. This point to this point. Undo that. Did that work? That worked, okay. Sorry, I thought I messed it up and had to do it again. We then counted the other 2, which we could have technically done minus 4 instead, but whatever. Subtracted these 2 bars, and then by adding a negative, and then by adding another negative, 2 times wheel spaces. So we need to count for these 2 as well. So we have this bar, this bar, this bar, this bar, and then the space these take up. So that is 4 what we have done, and then 2 of the wheel spacers, wheel space. And then that's pretty much it. We added the negative to that, and then we got this bar. So now we have the parameters. Like I said, those last few will be required to do annoying changes with. That I like make the length 26 instead. That actually kept it well. I don't think that adjusted. If I make this like 2010, yeah, that's when it starts messing up. Make this 15. That still kind of works. This distance doesn't change. That at least maintains its integrity, kind of. But yes, you see that everything will kind of these middle ones will have issues just because of the way they need to be moved, but the rest of them will be fine. The last thing we're going to do is make these all components. So right click, create components and bodies. Right, and the way I did that was, again, is I just selected the top one, held shift, and went to the very bottom and selected the bottom one, right click, and then create components and bodies. And you can select something by left clicking, and then holding control will select all the individual ones. And then selecting like this will select between two. You make it go up, you make it go down by going the initial versus the second. And then you can also select or turn off individual ones by using control. But trying to do shift will basically reset it to like the last point. From here, we're going to select all these, right click and create a rigid group, hit include child components, and hit OK. So now, now we can move this freely. Before we created that rigid group, I could freely move these all. I actually have to redo that. Okay, so select all these, right click, rigid group. Okay, we're gonna save. You should always be saving. So what do we do with this finished BAM frame? Well, now that we have all the pieces and the rigid group, there's many different ways to do joints. By joint, you can see there's many different types. Simple, between two faces, two edge intersection, then this motion, which we'll get maybe into at one point. The more important thing is these are all basically whenever you want two things to be fixed, but there still could be motion between the two. And creating a rigid group basically is if whatever you create the rigid group between, even if it's not touching, pretend they were touching, it creates glue where they are. So if I remove this joint and I move this piece over here, select it all over again, rigid group, capture position, okay, and move it, even though it's not connecting, we'll pretend it's like forced to stay the same distance. Undo that, undo that, undo that. So what this does is it basically welds the frame together by just creating a rigid group. We could create other joints, which we'll get to in a later video, but this is how to create the BAM frame, or at least the BAM, the frame, the basics of the frame at least. And that will be it for this video. Hope you guys enjoyed. Always save your work. Have a good one. Goodbye.